the utmost, just to comprehend those things which are there. They behave in a way that is like nothing that you have ever seen before. Your experience with things that you have seen before is inadequate, is incomplete. The behavior of things on a very tiny scale is simply different.
Casting Quantum Shingle proposes an experimental architecture of coastal protection, utilizing uncertainty as a design methodology. The project is situated within the unique geomorphic landscape of Dungeness, an exposed headland that comprises the largest expanse of uncovered shingle found in Europe. The site of investigation is an artificially formed shingle ridge, where the competing forces of nature and man present within Dungeness are observed at their most charged. The dynamic and uncertain landscape exists in a constant state of change, formed over the past 6,000 years through the action of longshore drift, as shingle is eroded and washed eastwards along the coast. The flat, exposed landscape of Dungeness becomes a canvas on which to observe the changing climate. The terrain is at the mercy of the weather, changing character dramatically from season to season and hour to hour. Historically, Dungeness can be understood as a testing ground for experimental technologies trialled on the shingle landscape. These range from acoustic sound mirrors to the artist Derek Jarman's pioneering Prospect Cottage Garden. The most notable of these experiments are the two nuclear power stations which stand at the edge of Dungeness, dominating the horizon plane. Their proximity to the ocean is necessitated by the role of seawater to cool the nuclear reaction process. This location becomes problematic due to the effects of coastal erosion and rising sea levels. As such, the power stations must be actively protected against the risk of catastrophic flooding. Having once provided energy to over 1.5 million homes, the nuclear power stations are now beginning the final phase of decommissioning, which constitutes the controlled demolition and removal of radioactive materials over the next century. With an expected end date of 2130, this then becomes the timescale dictated for the project's occupation. In the present, however, the power stations become the lens of uncertainty, a vessel through which the world of quantum mechanics is unlocked. The project has looked to the extreme depths of uncertainty that underlie the behavior of subatomic realms, exploring a language of waves, particles, and entangled fields. The proposal complements the existing coastal defense method of shingle recycling, where eroded shingle is transported back along the coastline and deposited in front of the power stations. This process has a detrimental impact on the local SSSI ecology and community, and comes at a significant annual expense of £450,000. An alternative is proposed which utilises the existing annual spending as a rolling source of income to trial an experimental architecture of flood protection. A design process is developed that utilises the uncertain energies of wave and wind action to weave structural strings into the shingle bank, slowing down the process of erosion. A parametric toolkit was developed that simulates this physical process within digital space. Periods of Dungeness climate data are sampled from as a form-finding methodology. The geometric outcome reflects the relative variance and magnitude of the incident weather forces. Further to the primary function of coastal defence, a strategy is developed which allows hidden forms of inhabitation to be carved out within the shingle ground, simultaneously providing protection for both the power station and the communities of Dungeness. Over time, this strategy is carried out along the 1 kilometre long shoreline, increasing the stability of the shingle beach. Consequently, a programmatic strategy of uncertainty is formulated that defines program based upon the needs of the community through time. The base geometry of a catenary arch is deformed through the simulation of weather forces within a parametric script designed specifically for this application. The dynamic construction process translates the movement of water and wind into the distortion of a series of strings laid over the top of the shingle landscape. Over time, this lateral movement results in the strings embedding themselves into the shingle. The mechanism results in the movement of flexible formwork that is dragged over the shingle surface, displacing and carving paths through the loose ground. This behaviour is simulated in digital space through the exploration of shingle as a fluid material. A performative construction sequence emerges, which fosters an architectural language of uncertainty. The 35-metre wide bank dictates the geometric parameters of the required architecture. Structural strings, constructed from a hybrid of steel and Kevlar, are laid over the shingle. Over time, the dynamic forces begin to reshape the bank as the strings embed themselves within the ground. Shingle is displaced as the structural members move through it. The process is allowed to play out for a period of 3 months, where it begins to reach a point of equilibrium. Impact moulding techniques are used to insert a steel tension cable that ties the base of the structural system together. A perimeter foundation beam is cast into the ground, resolving forces between discrete elements. A beam pad connection interfaces with the endpoints of each structural string. Formwork is buried within the shingle, after which ultra-high performance concrete is pumped through channels in perforated formwork, bleeding into the surrounding shingle. A highly irregular structural surface is uncovered, embedded with shingle aggregate. Openings are placed at the widest point between each beam. The rough shingle surface is used as a formwork for concrete to be poured. After casting, the lower chord steel cables are tensioned, preventing the structure from splaying outwards. Shingle is backfilled over the structure, submerging the concrete below. Finally, the loose shingle is excavated using dredging machinery, and the hidden space below is discovered. Loose shingle falls away from its solidified counterpart, revealing the uncertain cast forms within. The performative structural strategy becomes an unobtrusive architecture that integrates seamlessly with the landscape, stabilizing the shingle and slowing down the process of erosion. This process outlines a strategy rather than a finalized design geometry, and as such results in a myriad set of possible outcomes. In overview, the structure performs as an independent system, enabling the architecture to adapt to the changing landscape. Parametric tools are employed for the optimization of structural geometries and to analyze the structural performance in the extreme cases of storm flooding and gale force wind loading. A shingle architecture celebrates the material in multiple guises, where contrast between light and shadow, ground and sky is heightened. To begin the process of inhabitation, the uncertain structure is mapped using LiDAR technology to produce a digital representation that captures the uncertain tolerances of the concrete form. The subterranean structures are considered as microclimates, offering a baseline level of protection from external weather. Environmental simulations are used to formulate a computed understanding of the climatic condition within the submerged space. 6 metrics were chosen, ranging from solar exposure to wind flow analysis. Each metric becomes a climatic map of the internal volume, with values sampled on a 1 meter square grid. These values are categorized into distinct areas and overlaid onto one another to create a probability map of climatic conditions. As one traverses through the shingle bank, the microclimatic character shifts from region to region. Wind flow analysis is translated into Cartesian space and visualized as a swirling mass of air, forming vortexes as it's pushed by the prevailing winds. The climatic understanding of the structure is used as a basis to organize programmatic space. A remote residency is proposed with the primal functions of inhabitation defining each space. The parametric process outputs floor areas and spatial adjacencies based upon a codified environmental brief. The process results in a collection of bespoke architectural insertions tailored to the uncertain nature of the shingle structure. The hidden architecture reveals its presence through articulated coloured openings emerging from the bank. The steel frame language references the machined architecture of the power station behind. A translucent resin membrane interwoven with carbon fibre is fixed to the steel frame, whilst hydraulic pistons enable the frame to be raised and lowered, facilitating access to the spaces within. Dynamic apertures act as wayfinding devices on the shingle coastline, housing integrated lighting and radiative heating, whilst also mediating permissible levels of light and airflow within. Internally, discrete modules are raised off the loose shingle floor, separated from the concrete structure above. Circulation is enabled through an elevated mesh walkway suspended from structural cables, the boundary of which is computed using a shortest path algorithm. A monocoque construction method was developed for ease of fabrication, transportation, and assembly, supported on a framework of cast shingle foundation pads. Climatic qualities are celebrated through bespoke variations of the envelope skin, coated in a thermochromic paint that changes colour with the changing temperature. The transition from black to yellow marks the passage of sun across its surface. Coloured elements are carried through to the internal finish, where the spaces become animated by occupation within. Views to the sky and shingle outside are revealed. The project fulfills community functions, ranging from educational school visits with EDF energy to hired events, where the unique Dungeness landscape is used as a backdrop for the reception of weddings. The Shingle Bank also becomes host to a quantum gallery, a bespoke art installation where spectral forms reflect the surrounding shingle and the activity of those within. At the end of its required lifespan, the shoreline will eventually succumb to the forces of erosion. At this point, land will become sea as the shingle bank is lost to the waves. Looking forward 100 years, the dominating presence of the power stations are removed from the Dungeness skyline. Their memory remains, imprinted as a disturbance in the striation patterns that mark the shingle landscape. The project leaves a legacy of cast concrete structures embedded within the reinforced shingle shoreline, whose eventual condition remains a subject of uncertainty.